Alright, welcome to Jaka Quantics. Now in this tutorial, I'll be putting us through how to measure retaining walls. Alright, how to measure retaining walls. As you can see from the screen, this is a typical retaining wall. Right, retaining wall are basically structures designed to hold back soil or rock or any other material on a slope or an embankment, just to prevent their collapse. Right, they are structures designed to hold back soil, to hold back rock, or to hold back any other material on a slope or an embankment, basically to prevent their collapse. Right, could be also be to prevent erosion. All right, so that is a retaining wall. Now, as you can see from my drawing here, we have a typical design for a retaining wall with the respective details. Now, I have this drawing has 4-number retaining wall. I just picked one. They are of different sizes. All right, so let's concentrate on this very one here. Right, now this is the depth. This is what we have. All right, this is one level of the soil, this is another level of the soil. So this is the lower level of the soil, this is the higher level of the soil. Now between the lower level and the higher level, we have 2000 to 2500. It ranges, right? From here you can see the actual depth of the retaining wall. From down here down to this particular point is the total depth, or you call it height of the retaining wall. All right, and you see the reinforcement there. This is this member is Y12. These are the ones you see dot through this section is the runners. Right, you call them runners or distribution bars. All right, now of course, now you see the main bars at the back is Y12 at spacing 200, while the main bars in the front, also to say whichever is front or back, is Y12 150. So as a professional, you need to pay attention to these details. All right, this project, I was involved in it in 2021. In 2021. All right, so that's when we executed this particular project. All right, so this is basically what we have. We want to see how we measure a retaining wall. Of course, if you look at it very well, if you've been following our classes, you will know that you have excavation, you have concrete works, you have reinforcement, and you have formwork. Majorly because it's a concrete structure: excavation, concrete works, reinforcement, formwork. All right, as the case may be. All right, let's see this here. This is basically what we have here. All right, so we'll be using this particular design, this drawing here with this detailing, and we are going to be working with this here. All right, now this is the detail. All right, project title is retaining wall. The length, we're working with 100 meter or 50 meter. I changed it to 50 meter. 150 meter, say 50,000 millimeter. All right, millimeter, right, which is 50 meters. Okay, let me leave it at 50 meter. This is what we have. Our 50 meters multiplied by 1000 is 50,000 millimeter. All right, this is basically what we have. These are takeoff list. We have excavation, that's site preparation, cutaway, backfilling, concrete works, blinding reinforcement, formwork. Basically what we want to do. Alright, now if this is an exam situation, right, you see all the details, like I always say, they are very, very important. And even if it's not an exam situation, but you want to show your boss or your senior colleague, you have to put out all these details. Alright, I've told us the importance of a takeoff list. If you're writing an exam and you were not able to finish, it tells your examiner understands that he knows what he's doing, what he could not finish. You get, even when you don't know what you're doing. But because of the takeoff list, time could not permit him, even when you had all the time. Alright, okay. So basically, this is what we're looking at now. Now, for exam purpose, for those preparing exam, if you're working on large structures like this, maybe retaining walls or bulk excavation or other large railway, road, right? There are plants you work with. They are not just, you can't do them manually. You work with heavy machineries. So you just allow for mobilizing and demobilizing plants out of sight. Allow for mobilizing of plants required for the works. There should be demobilization somewhere. If it's not there, you put it. Demobilization. You have to bring to site. You have to remove from site. All right. So excavation and filling. We said it is 50 meters. Right, which is 50,000 millimeters. The width is 1,500. Right, that's the drawing. 1,500. The thickness of the base is 500. The wall itself is 250 millimeters, which is 0.25 meters when you divide by 1,000. All right, so this is what we have here. Of course, we need to clear the site clearance, remove vegetation, and our reference document is the BESMM4R. Right, that is the guide. It guides you on the steps to your measurement so that you don't miss out items. So site clearance is a square meter item, 50 meter by 1.5. Now, on the taking off sheet, you have your waste calculation. If you're writing an exam, waste calculation is on the right. If you're writing an exam, you'll be given a takeoff sheet that has been a paper to work with by hand. Your waste calculation should always come on the right. Please take note. I'm using Excel. All right. This is our site clearance, 50 by 1.5. Okay, then after having cleared the site, now we need to excavate. All right, so we are commencing from, of course, our site clearance. We're going down and the depth is 500. It is as straightforward as it is. 50 by 1.5 by 0.5. Now you see I didn't put any pool workspace or no pool workspace. BSMM4, like I said, I've said it over and over. BSMM4 does not support that. It has to be in your rate. Please take note. Alright. So, and I've explained this before, using AND to link up to description. Using AND to link up to description. Now, if I separated them, if I bring this one here and put it here, right, for disposal, I'll still be right. Right? It's just you telling your examiner that I understand this concept. I know how to do it. That is why you see you're using AND to link up to descriptions. but of course you see their BSMM4R references are different, and again they are the same units. So this is our excavation. This is the plan here. It is 1,500. This is the depth of the footing. It is 500. Well, there's something I didn't allow for. It is the blinding. On this project, the blinding was 50 mm, not 100. It was 50 mm. So this is going to be 0.55. Now you can see I didn't square. I didn't square anything here. Right, because I am not preparing a bill of quantity. I am only showing you how to do the measurements. If I'm preparing a draft BOQ, maybe in an exam, the NIQS exam, a draft BOQ, I don't need to square. I am not supposed to square, because a draft BOQ does not carry quantity, it does not carry rate, it only carries unit of measurement, right? Which are these, the meter cube and this. So let's continue so that can be a little fast. All right, concrete works. This is still at 100 ml. Let me bring it down to 50,000. Now concrete works. We know the length of the retaining wall. We know the weight. We know the thickness. We also know the base. Right, any retaining wall is a concrete structure. Any retaining wall is a concrete structure. All right, now first is the blinding. Of course, before you start doing, because you have to blind before you place your reinforcement, and then you can undo the base. All right, so plain in situ concrete grade 15, or sometimes grade 10. Right, horizontal work less than or equal to 300 mm thick in blinding poured against unblinded earth. BSMM4R 1.11.2.1.1.1. I will not be saying all these things, otherwise this video will be 1 hour today. All right, this is in cubic meter. So the length is 50. That's the base now. The width is 1.5, and the thickness of the blinding is 50 mm, which is 0.05. All right. Having done the blinding, the next is the reinforced concrete. Reinforced in situ concrete grade 25 in bases. This is no longer less than or equal to. This is greater than. Where's my greater than safe? This I got it. Greater than or equal to. Because the base is 500 mm. It is greater than. Right. So these little things you need to check out for. Alright, it is in cubic meter also. This is the length. This is the width of the base. This is the thickness of the base. Now the wall. Ditto in wall. The thickness of the wall is 250 mm. Right now. Thickness of the wall is 250 mm. Right. Now this is the effective height of the wall. Right. Now this is, you see, this range is 2,000 to 250. So the wall at that time was 3 meters. I said I did this project in 2022. Right, the wall was 3 meters. All right. Now you can see here. This is the depth here. This depth is below ground. This is part of the retaining wall. Now if this is 2.5, this is part of the retaining wall also up. So this is 2.5. Then I have 250, and I have 250 that is below the ground here. That is 3,000 millimeter. So as I see here, 3 meter, 50 meter by 0.25 by 3 meters. All right, so that is that about the concrete works. Any retaining wall, that is how you measure the concrete length by the width, by the thickness. Length, width, by the thickness. Same thing goes for the base. All right, now let's see the reinforcement. Now, for structures like this, normally maybe the civil engineer that designed it, or the structural engineer that designed it, gives a bar bending schedule. But if we don't have a bar bending schedule, what do? Now, as QSs, we don't wait for bar bending schedules. If it comes, great, but if it doesn't come, great also. All right, so let's see the reinforcement. Now, firstly, we see the reinforcement to the base, and then the reinforcement to the walls. Now, this is what you see. This is the shape. You can see this. Right, this is the shape. See my cursor here. This is the shape of the reinforcement to the base. Now, this is basically what we have here. This is the section here. Right. So that's basically what we have, which is what I have here. Right, so I tried as much as I can to put the details here. The width is 500, the depth is 15, depth is 500, the cover is 25 mm, bent is 150 because it's a retaining wall and you have a deeper base. Right, there's no hard and fast rule to the bends. Your drawing will tell you what it is. Now, if you see what I have here, this is, now look at this. Let me zoom in. Now see this shape. See what I'm talking about here. See the length of this bend. Right, see this, see this, see this. Right, normally I'm surprised. This is supposed to carry a chair, given the depth of the base. There's supposed to be a shear bar, right? They call it, the layman call it shear, right? Something like this, right, to support both the top and the bottom reinforcement. But this design didn't show it. It should be a shear bar. All right. So this is basically what you have. The depth of the base is 1500. Right. For me to see the cover, I need to the width of the base rather is 15, which is this here. This length here is 15. For me to see the reinforcement, I need to less cover, which is 2 by 25. And of course, I add bent, which is what I have here. So total is 1750. Let's go to page 2. Now, retaining wall length is 50,000. For me to know how many bars I'm going to have, we are told that this is one thing that drew me to this particular drawing. For this in the front here, it is Y12 at 150 center to center. 150 center to center. Why the one at the back is Y12 at 200 center to center. In most retaining walls, they are the same thing. Most retaining walls, if this is Y12, this is also Y. If this is Y12 200, this is Y12 200. Alright, so that's basically why I used this. Is Y12 150, and if one is not careful, you just say Y12 150, you multiply by 2 because they are two, because one at the front and one at the back. You'll be very, very incorrect. Alright, so okay, it's basically I am. Let's continue. So this is the reinforcement. This is 1.75, which is what we calculated here. Right, by the total numbers by 2. Now, one other thing I want to understand, I want to make clear. So let's come back here. Let me show something in the drawing. Good. Now, you see the base here, right? This is the main bar. See the dotted lines? They are the runners. Okay. Alright, so this is what I have. Now, okay, now this is Y12. Let me put this here. This is in tones. This is in tones. All right, now I've explained this before. I said if you're doing anything, this is a takeoff, and you did not put this to show that it is in tone, you've converted it to tone, you're wrong. And I've explained this in previous videos. Please check up on our previous videos on similar topics. All right, how we arrive at the 0.888 or 1.578 or 0.616 or 2.45, right, for 20 mm. Please check out on the videos. All right, now the runners, that's distribution bar. That means when I mean distribution bar, these are these ones that runs the entire length of the 50 meters. All right, so this is what we have here. The length of the distribution bar is 50,000, and the number of distribution bar, they are running towards 1,500. Right, so 15 divided by 150 plus 1 is 11. Okay, that's good. All right, so this is what I have. So the total length is 50 mm, the total number is 11, and then we have it by 2. By 2 means I have one at the top. All right, you can see this dotted line at the top, then I have them also at the bottom. So that is that with the reinforcement for the base. Now let's go to the walls. Okay, I added something, laps, concept of laps. Now the length of the retaining wall is 50 meters. It's 50 meters. Right, and the reinforcement is max 11.7 or 12 meters. So there at some point they will need to join these reinforcements. All right, that's what we call laps. So I said they are being joined at 1 meter. How many laps are we going to get? That's 50,000 divided by 11.7. All right, so we're going to be 4.27, which is 5. It has already entered point 5. All right, or normally you'll say if it's not 4.5 or 4.4, it has entered point 4.2, 4. The remaining to 0.27. What are we going to use to join it? So we have this 5 by 2 because it is both top and bottom. All right, and also this must be there. It is y12 by 0.888 divided by 1000. Very important. Then the walls. We've done for the base. Now I want to look at the reinforcement for the walls. All right, but the wall, this is length of main bar. The length of the bar is 3000. The depth of the base is 500. Now bent at bottom is 500, bent at top is 150. Now I just worked in accordance with the drawing. The drawing will tell you what to do. Now see this is this reinforcement here. Oh, I was working at, okay, this is this reinforcement here. Now you can see this bent. You can see this bent. Right, they are more than this. Alright, it will be unfair to say, okay, this is 150, or this is 300, like I used for the base to use for the wall. So please observe your design very closely. And of course, if I'm working with blue beam or plan swift, right, I don't have to. I can ascertain this. But given an exam situation, you don't have the liberty to be doing all this. But of course, you can scale. You can use your rule to scale. You can use your rule to scale also to arrive at this. All right. So please kindly take note. Say also one tutorial, use 500. It is not so. I am just working by observation. I am working by observation. Right, okay, this length is more than this. All right, let's see, let's continue. So this is the length. We add the base. See the reinforcement here, right? It's almost here. So you just sit at the base, then I remove the distribution bar. I remove the main bars and distribution bars. Right. Let's cover. Add bent at the top, add bent at the bottom. It is not finished. I didn't, because I used the complete base of 500. I need to less bring this one down here. I need to less remove this. Okay, I need to remove the distribution bar because I use the complete base of 500. Otherwise, what it means is this: I use the complete base of 500, but the reinforcement didn't get to the base. There's a member, there's a cover one, there's a member, and then there's a distribution bar. Cover is 25. Both member and distribution bar, they are both 50-50 mm, which is 100. So I first of all I remove the cover, which is 25. Remove member. Remove distribution bar. Right. Minus. Okay, no need to put equal to. Okay, I get it. 50-50, that's 125. Okay, I see. Minus 125, that's the way the page is. Alright, so this is what we have. That's what it should be. Because this is blinding. Sorry, it's a blind. This is cover for me to see the reinforcement. Right now, but I added the base, which is 500, the complete base. But if the reinforcement didn't get to the base, if you can see my cursor here, this is one, this is one. So we still have a member because it is sitting on the reinforcement at the base. So I need to less those to give me a good answer. Now, this is an exam situation. This is an exam, but if it's not an exam situation, those little figures I can do away with. Right? I can do away with them. You don't have to. I'm telling you categorically, you don't have to. But if it's an exam situation, you have to, because these are the things your examiner wants to see. But if I'm working on a job, I don't have to. They are minimal. All right, so let's take note of that. So that this is 4 points. This is 4. All right. So what is the total number? They are running through 50,000. This is the one at the front. Like we were dealing with the base before. All right. Please take note. I think I missed out something there. I was showing the picture for the wall. So that was for the base. All right. So if you divide by 150 plus 1, is give me 335. Sure. So it is 4 numbers by 335. And of course, this is high yield reinforcement steel bar to BS 4461, 10 to 16 diameter, straight and bent. Of course, you have straight, you also have bent on it. And this is a T12 01150 C2C main bars. This is the base mm4R. So this is the conversion to tone, 16 mm. Okay, it is 12 mm. What told it is 12 mm. See it here. This is Y to 150. All right. So that is basically what we have. All right. The next is the reinforcement at the back, which is this reinforcement, and we're told that the reinforcement is 200 spacing. That's 200 spacing, not like this that has a 150 spacing. You are still dealing with the main bar. This is the main bar. I've not got into the distribution bar yet. Alright, this is 50,000 divided by 200 plus 1. We'll do the same thing here. This is 4.00. This is 4. Alright, we already calculated it. Right, by 251. The number of information at the back is actually less than the one you have in the front. That is the peculiarity of this particular design. That's why I use it anyway. Alright, unlike other, you see this is Y12, this is Y12. Or whatever is at the front is the same thing as what is at the back. Alright, so now the distribution bar. I've explained distribution bar several times. See this dotted line. They are running through 50 meters. All this dotted line, Y10 at 200, they are running through 50 meters. Alright, so this is basically where the length is 50 meter. The number is they are running through the height of the retaining wall. You see them, you see them, you see them. Alright, through the height of the 3 meter height of the retaining wall, and they are Y10. So 3,000 divided by 200 plus 1, I have 16 numbers of them. So this is basically what I have. 50 meters by 16 by 2. By 2 means I have one at the back, I have one at the front. This is what we have here. This is the drawing. There's one at the back here, and there's another at the front. Right. You cannot cram measurement. You cannot cram measure. They don't cram measurement. It is what you see in the drawing and your knowledge of the construction process. Right? It's not something you cram. If you're a student, it is not something you cram. It's something you know. Right? You study, you understand the drawing. You know, you understand the construction process, and it becomes very smooth for you. All right. So by 0.616 by 1,000, that is Y10. All right. So the formwork. Formwork, we have formwork to the base, we have formwork to the walls. Right. Now the BSMM4 says if it is less than or equal to 500, it is a meter item. If it is greater than 500, it is a square meter item. It is greater than or equal to 500, it is a square meter item. So we have it at, we have the base at 500. So I treat it as a meter item. Now if another person should treat it as a square meter item, would the person be wrong? No, because the rule is less than or equal to 500, greater than or equal to 500 if you check the BSMM4. Alright, so we're treating here as a meter item. This is 50 by 2. I already state the height. All right. Now, of course, this is. Let me show something. This is it here. This is the 1/5 part. Of course, this is another part I need to put formwork. I've done here, going through the length, then it's 50 meter, then the 1.5 by 2 part also 1.5 meter by 2. Let me come here, let me show us through here. Right, now this is what I have, this part here. Right, remember this retaining wall is running through 50 meters. It is running through 50 meters. So this here to the 50 meter length. All right, I need to put this at this side and at the other end, at one end and at the other end, which is what I just did here. This is the first one, right, and this is the one at both ends. Now for the wall is running through 50 meters. The height is 3 meters. So I have it by 2. 50 meters by 3 meters by 2. Now this is a detail greater than or equal to 500. It is a square meter item. is a square meter item. Now, having done all this, let me bring us to the drawing. Right. Having prepared a retaining wall, right, this place is opened. You have to backfill. You have to backfill this to the depth of this particular top sand, to the height of this top level of the sand. It still be below the ground depth. Alright. So I have to backfill. Of course, what the small thing you excavated will not be enough. You have to import sand. To do that, is imported filling. Imported filling. Right, total depth of fill is 2750, because the height of the retaining wall is outside. The 250 part is outside, so the remaining part inside is 2750, which is basically what we have here. So this is 50 meters by 1.25, which is the width. How do they arrive at 1.25? It is from here to here. 15 minus 250. We get the filling width to be 1.25, which is basically what we have here, by 2.75, which is the depth. Brought this here. So, and of course, remember when we started, we brought in plants, and now we need to take out our plants out of sight. Allow for the mobilization from site, plants used for the works. So this is basically how you measure a retaining wall step by step. It's excavation, concrete, reinforcement, and formwork. Now you see, like what we just did here, the reinforcement, they are not the same thing. The space, they are the same thing, but the spacing are different. Sorry, the reinforcement, they are all white 12, but they have different spacing, both for actually for the wall, the one at the front and the one at the rear. They have different spacing, so their numbers differ. And also seeing that for the base too. Alright, this is basically how you measure a retaining wall. Right, a retaining wall can also be a gravity wall. Right, can also be a gravity wall, but this is basically how you measure a retaining wall. Alright, well, this is Chaka Quantics. I hope this helps in your academics, in your professional career, on your next job. I'll see you in the next video. Thank you.